Modern digital infrastructure is an ever-expanding maze of code. Thousands of interconnected systems continuously build outward, creating vast, complex structures, where critical vulnerabilities easily hide in the dark. This illustrates the core law of cybersecurity asymmetry. To keep systems safe, defenders must successfully secure millions of lines of code. An attacker only needs to find a single crack in the armor to compromise the entire system. Historically, defenders have guarded these immense perimeters using a mix of manual human code review and automated brute force tools called fuzzers, programs that endlessly throw random data at software to see what causes it to crash. But the sheer volume and accelerating complexity of modern software updates have vastly outpaced the capacity of those traditional methods. Codebases grow faster than humans can read them or fuzzers can brute force them. Because of this disparity in scale, deep flaws slip right past our defenses. They embed themselves silently into the foundation of the software we use every day. These are not just minor glitches. They are high-severity threats lying entirely dormant, waiting for an attacker to discover them. Relying on human-driven analysis to protect infrastructure at this scale has reached its absolute limit. Our systems remain structurally fragile, and the defenders are perpetually outgunned. To actively hunt down these latent vulnerabilities inside the Firefox browser, the Mozilla engineering team launched a new initiative. Their primary tool for this project was an unreleased model from Anthropic known as Claude Mythos Preview. Simply throwing an AI at a massive codebase usually fails. Prior attempts at AI vulnerability scanning generated a deluge of slop, an overwhelming amount of false positives and useless data that wasted time. This diagram shows the mechanics of Mozilla's technical breakthrough. Instead of letting the model run wild, they combined the AI's reasoning capabilities with a custom orchestration and filtering layer. This custom pipeline allowed engineers to strictly steer the model's output. Every finding the AI suggested was systematically validated against real-world parameters before a human ever had to look at it. By structuring the workflow this way, Mozilla converted the model from a sloppy guesser into a high-fidelity radar that produced almost no false positives. In their April release, Mozilla's security bug fixes shot up to 423, with 271 tied to the Mythos AI. Look at this specific data point. A 15-year-old audio bug that had survived a decade and a half of intensive human review and automated fuzzing. Finding a defect from 2011 shows that AI perceives architectural blind spots that human review and automated fuzzers consistently miss. For the first time in internet history, artificial intelligence is aggressively tipping the asymmetric scales back toward the defenders. The immediate impact is clear. Defenders finally possess a tool that can match the immense scale and complexity of the software they are trying to protect. But this creates a critical dual-use risk. The same reasoning capabilities that allow an AI to identify and patch defects also make it a potent exploitation tool. Threat actors can adopt these exact same orchestration pipelines to automate their own discovery, streamlining their ability to attack unpatched systems. This places intense pressure on the entire software ecosystem. Vendors must now accelerate how they coordinate patches and disclose vulnerabilities before an offensive AI uncovers those identical bugs. When automated pipelines uncover hundreds of vulnerabilities in a single month, the time defenders have to act shrinks from months to mere days. As automated discovery reaches this scale, the traditional model of human-led security reaches its limit. In this environment, the safety of our digital infrastructure depends on maintaining an algorithmic edge over those